Hello, everybody. Welcome to another round of the OAuth Happy Hour with Aaron Parecki and Micah Silverman. We are here
Hello.
streaming to YouTube and Twitch today, so if you are joining us on either platform, welcome and nice to see you. The rough plan for the next hour is to just chat about all things OAuth and share some updates about what's been new going on in the space, and happy to answer questions as well. So if you do have questions, drop them in the chat and we will see if we can get to them during the stream.
Sounds good.
Yeah, so this week has been an ongoing event called Internet Identity Workshop, and that has been a lot of fun. Lots of good sessions there. That's an event that usually a lot of OAuth work is done sort of off the record there. It's not part of the group at all, but a lot of the OAuth community gathers there and brainstorms things, and a lot of the early OAuth work happened there as well over the last 31 events. This is the 31st workshop. They do, I think it's 3 a year. And yeah, it's always a lot of good discussions. It's about all things internet identity, and OAuth is obviously wrapped up in that.
I went last year and I wasn't able to go this year. So I have two questions. One is, what kind of great OAuth stuff did you either hear about or talk about? And the other is, what non-OAuth topic kind of got your attention this year?
That is a good question. So yesterday was I think my favorite day, and there was my schedule was just booked up the whole day. Like every slot, it's an unconference, so the agenda is made up like during the morning of every day. So you never know what's gonna happen until you show up. And there was a lot of good stuff yesterday. So let's see. There was a session in the morning about what happens after OAuth, and we're talking about the alternatives that are being brainstormed in different groups. GNAP is one of those, which we've talked about on the stream before. There was another one that I had not heard of yet called ZCAP, although it turns out that it was sort of like an evolution of some of the other work that I have heard of before. So that was a really interesting discussion, and a lot of the OAuth folks were in the room there and had a lot of good things to say about what any future work can learn from the experiences of OAuth, because I think there's a sort of general worry from people about new efforts popping up and saying, oh, OAuth is terrible because it's too complicated and blah, 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 because they never really understood it, and then reinventing something that ultimately ends up being just as complicated or worse because it was not, the problem space wasn't fully understood. So that's, I think that's a lot of what myself and the other people in the OAuth community are trying to like help people understand, is that yes, OAuth is complicated because the space is complicated. Nothing about this is easy, and it's okay. But the solution is not to just throw everything out the window that's been done before and start from scratch, right? So that was a lot of that discussion there. What else? What happened next? We had, let's see, I went to a session which was, oh, that's weird. Now I don't see it on the agenda. Oh, yeah.
Stricken from the record.
It was called, does self-sovereign identity require DIDs, which is a lot of jargon that is used in that world. So there's a lot of the sort of new stuff going on at IIW at the event is around this idea of self-sovereign identity, where the identity is not controlled by the major players. Like you don't use your Google account to log into stuff. You bring your own identity and log into stuff, which interestingly was the original goal of like the OpenID world. So there's a lot of sort of shift back to that idea, and what's happening right now is there's a lot of blockchain happening. A lot of blockchain being talked about. Most of these solutions that are being talked about use a blockchain in some way to do this. So a DID is a way to turn I guess, some sort of identifier that involves usually a blockchain, but not necessarily, into something resolvable that you can actually get data from. So the sort of non-blockchain version of that is a URL. It is a string that means something, and you know how to use it, which is you go make an HTTP request to it and fetch data from that URL. So
Sounds very indie web.
yeah, kind of, except not web. It's completely off the web is the idea, where it's using alternative transports instead of the web. But that session was all about challenging that assumption that you need to be on a blockchain. What if you could do that kind of thing, but on the web, where things actually work today and mostly are fine?
And so is the TLDR there that we trust DNS for the most part, and that's kind of like the proof. Like if you can get to a URL, that's proof enough.
That's both the positive and the negative at the same time. The positive is that DNS actually works fine, is completely scalable, is a gigantic worldwide database the same way a blockchain is. It just happens to be architected, or rather controlled, in a way that is very hierarchical and coordinated by few governing bodies, right? There's like, what is it, like 6 or something different people that have like the keys for the root trust, and they have to like do those signing ceremonies every couple of years or whatever it is. But like while that's not the same as like, everyone's completely independent, it's also not necessarily bad. And that's a lot of the discussions that are happening right now in this world of like, well, if you just say that it's completely bad for DNS, like DNS is bad because it's top down, then you're actually missing a lot of the nuance there, because it's not top down the way that like Facebook just decides what Facebook does, right? Facebook is a company that acts actually mostly monolithically, and they can make a decision and then just do whatever. That's not how DNS works. And the other problem is that any alternatives are going to end up being centralized around some other thing anyway. So DNS is centralized around the fact that there are a few root zones that then branch out into all the different leaf nodes on the network, where you get control over. You can go buy or rent a domain or whatever you want to call it. You're paying someone here for the ability to edit the records below it. You can then do anything off of the subdomains you want, right? And it's kind of that. And actually resolving, there's the whole like going up the chain until you find the name servers, et cetera, et cetera. There's caching name servers within the chain. Anyway, so there's a lot of arguments why that's bad, which some of them are fine, are valid, but the alternatives being proposed, people don't often see the forms of centralization they're adding to those alternatives. So a blockchain is not decentralized. A blockchain is it is a distributed ledger, right? It's a agreed upon convention of rules.
Eventually consistent.
It's an eventually consistent database. It is a database. It is the rules that are agreed upon are things like the algorithms used and how which keys, which kind of cryptography goes into it, and all those things are agreements that somebody has to make. Somebody has to agree on these, right? Multiple parties have to agree, and if people disagree, then you end up with breaking that network. Either it becomes not functional, or people can take it over if they decide to go a different direction with it. And so there is a form of centralization there, which is that people agree to play by the same rules. And that does not have the decades of experience that managing DNS does, where sure, there are some problems with the way DNS is managed, but also a lot of it works really well. And we've gone through a lot of these problems. So that's sort of the big discussion there of like, there's a lot of unknown problems that people are going to hit once you start managing these things at the scale of the entire internet and on all of DNS. Anyway, that's getting way off topic from OAuth. But that was an interesting discussion. One of the other things that is actually very relevant to OAuth that's being discussed at the event and at come at future events coming up very soon is WebID, which is a proposal by Google to make the browser more involved in the process of signing into things. Because right now, the idea, like right now, the way that everything except HTTP basic auth, which nobody uses, everything else is bolted onto the browser, right? So we've got like all these different tools available, like redirecting the user or popping up windows or using iframes or using cookies, all these tools available that can be used for other things as well as signing in, as building a login experience. And we use them to build a login experience. And then the problem is that they get abused for ad tracking. So the classic one is like iframe trackers or where you can drop an iframe to some other ad tracking site on your website. This is like the Facebook comment box is this. It just disguised as functionality. But as soon as you drop the Facebook comment box on your website, and every time anybody loads that web page, it's also loading Facebook. And now Facebook knows all the sites you visit, which means they can then retarget ads at you very effectively. And it's unfortunate that the way that login works is built using the same building blocks, which means if browsers are trying to stop ad tracking, which they are all trying to do, then they're also going to be breaking things that make login work on the web. So they don't want to break logging into stuff. They do want to stop ad tracking. So how do you do it, right? And Safari is going down the road of like using machine learning to identify websites' behaviors and block things sort of heuristically. And Google is instead trying to trying to add a new building block, so that if you are trying to build a login experience, then you can say, I'm trying to do a login, and then the browser knows that these certain things are okay to allow, right? So if you say this is a login experience, then all of a sudden the browser might allow cookies to be shared across domains in an iframe, whereas it wouldn't if it was for an ad tracker. So it's an early proposal right now, but it's a lot of good work being done there, and they are actually like going around to the relevant communities like IIW and W3C and the OAuth group, and actually like bringing this up, getting feedback, and looking for feedback on that. So I'm optimistic about it, and it's gonna happen really fast now. Like things are moving. Over the next couple of months, I think we're going to see a lot of movement there.
It's interesting because OAuth itself is very agnostic to all of this. It doesn't care about or I think even have knowledge of cookies per se, but that's kind of how all the implementers have kind of worked with it.
Well, I guess it depends on what you mean by OAuth, right? Because OAuth, if you think about just the core spec, all it's defining is the communication between the OAuth app and the authorization server and the resource server. But in practice, you have to build an authorization server. And there's a lot of things involved in building that aren't in a spec because they're just implementation details. And then you have to define how your resource servers talk to your authorization server. And there's all these little pieces that end up having to be built that aren't described in the spec because they're just part of building it. And that's where these sort of edge cases come up, or that's why you see cookies all the time, because that's how a user can be logged into something in a browser right now, right?
Right. Yeah. Didn't I see something this week where they're trying to formalize the communication with web workers to be able to use that as a better source for things like tokens? I thought I saw something about that this week.
I have a memory of seeing something fly by this week around that. That idea we've talked about here before, I think, where I saw an implementation, and I think the source was on a GitLab or something. Anyway, there was a write-up of the technique of using a service worker to manage all the tokens for a JavaScript app. I don't remember what was the thing that flew by this week around that, but yeah.
Yeah, I'll see if I can find it, but yeah. We have maybe my favorite question so far. We'll get to as many as we can, but I like this question.
Yeah. Does writing OAuth 2 and OpenID Connect from scratch in a TypeScript Node.js Express make sense? So I guess first question is, do you mean OAuth server or OAuth client? Because there's a huge difference there, right?
I assumed the question was about server, and if so,
Okay.
my answer would be as a science experiment or to learn the spec, sure, awesome. As, something that you want to put into production, I would say probably not, only because there's a lot of other really great stuff out there already, open source, well contributed to. Why reinvent the wheel?
Yeah, that is a very very good point, and there are a lot of open source projects, open source OAuth servers in many languages already, which definitely like at least take a look at those before building a new one, because chances are they want help, right? Because it's not a small project building one of these things. There's a lot that goes into it and a lot of stuff that you don't necessarily think about when you start. So hopefully these more mature products, open source products, already have gone through a lot of that work. As far as OAuth clients, though, the again, there's a lot of pitfalls. It's easy to make mistakes, so definitely take a look at the existing libraries and solutions for clients. But it is a lot less work than building an OAuth server, and it is possible to do it well from scratch if you really need to. Chances are you actually don't really need to. So again, like really think about why you're doing that from scratch. But the good news is it's a lot easier to not shoot yourself in the foot when you're building an OAuth client. One of the things that frustrates me most about a lot of the open source OAuth clients I see is that they tend to over abstract things and then expose some new API to you as a developer that is so different from the OAuth spec because they're trying to like make it easy or something, where they end up just confusing it so much. And it's actually then you have to learn two things. You have to learn what OAuth is, and you have to learn how to use this library. And it would just be easier to just do the redirect yourself or whatever it is. So that's one of the reasons that like, if I've decided to go and add, GitHub sign in to a new project, I may not use a library for that because the library is just like bringing too many other dependencies that I don't want in my app, or it is way over architected and I don't understand the APIs they've defined, and I would rather just take the 10 minutes to build the OAuth client from scratch for that.
Makes sense. So what else from IIW? Anything that you found that might have an impact on the 2.1 work that's underway?
Yeah, honestly, I think the WebID stuff is definitely interesting. It's not going to impact 2.1 probably because that's, I think, well enough scoped to not be affected. But it is going to affect sign-in in general on the web, including OpenID Connect and more. So that's definitely something to keep an eye on if you're interested in that layer of things. Then the it's a new API to keep an eye on, and soon, quick, like get involved now. There's an event on the next OAuth event, interim meeting, or not the next one, 2 from now. Oops, wrong event site. On November 2nd, that's actually coming up pretty quick. There's an interim meeting with the OAuth group talking about that spec, and it'll be an overview of WebID plus also the new is logged in API, which is from Safari. And then they're also presenting it at the W3C event, which is called TPAC. Let me see, I think I have a link somewhere to TPAC, and that is, let's bring it to the larger W3C. There it is, the larger W3C community. Here we go. And this year, TPAC, which normally is only available to accessible to members, it's actually open to the public this year, which is cool. So if you are interested
Hmm.
in web stuff, it's worth attending that because there's going to be a ton of breakout sessions. Cool. Oh, Matt found the thing. Cookie Store API. And I can't click links because they chose them on the screen. So yeah, that is the new API that talks about, it's an API to let service workers use cookies. Is that right?
Yes. Or to asynchronously interact with that and have it be like a secure cookie store.
I thought this was just about a new cookie API, not necessarily related to service workers.
Oh, maybe. I was thinking about the service worker business. That was the thing I recollected passed by
Yeah.
this past week.
Well, I have a feeling I know what's going on. So let me share this. Um,
Yeah.
this window, Cookie Store Explainer. They always do these explainer documents, which are really helpful, where they talk about the like high level goals of these new things. Um, this is so yeah. The idea, I remember reading this. The idea is that normally the cookie API is like a giant mess where you get the entire cookie string and you have to parse it out yourself. So they always end up being like cookie libraries to just do the parsing. So, and they end up looking like this kind of stuff, right? Which is a mess. So the idea is there's a new API which is an asynchronous API, which is important, but it's also just a cleaner API to get cookie values. And I think the reason it's asynchronous is so that it can be used in a service worker.
I see.
So, because I don't think that it would be able to be used if it were synchronous. So, because it's an async API, it has the ability to use in a service worker. But I don't think that it's exclusive to service workers.
Gotcha.
Oh, there's a event handler which service workers can listen to. That's very cool. Yeah.
Neat.
Yep. Let's see, what other questions we got in here? I like this question from Heather. You think social providers like Facebook or GitHub will still be popular to use for signing into websites in the near future, given how many users are leaving social media? Yeah, this is a good one. I think even though people are leaving social media, I don't think enough people are. Like, I think there's still so many people on them, and that's not going to change anytime soon, unfortunately. And the other part of that is I've already seen, like, I hear a lot of people deciding to use or not use a social login for different reasons intentionally, both ways. So I might intentionally use GitHub login to log into things where I don't trust that website to keep a password, right? Like, I would just rather not have a password with this website. So, like Travis CI, I don't have a password there. I just use my GitHub login to log in there. That's fine. However, I then intentionally don't use a login with a website if I don't want it to be able to correlate me on other sites. So, people will often use a unique email or unique username to create an account on a website when they don't want that website to know where they are elsewhere on the web. So I think that's interesting that behavior already exists and is actually pretty widespread, and there's arguments on both sides of using social login to do that, right? Same kind of thing with Apple, where Apple did a really cool thing, which is you do the anonymous email trick and return app-specific user IDs so that apps can't correlate you across sign-ins. But some people still may not want to sign in with Apple for other accounts because Apple knows.
Yeah, anecdotally, I've seen, at least in my particular experience, there are two websites, paid websites that I use that have removed the ability to log in with social. So like I'll go to the front door of the site and it'll say, you can no longer log in with Facebook. If that's how you were connecting in the past, click here to go set a password. That's happened like on two different sites that I use, and I don't know if that's a trend or how widespread that's becoming, but that was an interesting data point. And then the other thing that's kind of related is people that use password vaults, especially shared with family, which is also something that I do. For certain things, we avoid logging in with social because we want to be able to share that account using the password vault, and we don't want to have to get stuck with logging in with Google and having it send a pop-up confirmation to the device or something with MFA. So that's kind of an interesting,
Yeah.
like, counterintuitive anti-pattern to signing in with social.
Yeah, it's a really good point. And I think both of these things point to sort of larger problems in the industry, which are sharing access to accounts and avoiding tracking. So there's a lot of the discussions happening at IIW, for example, are around privacy when you're logging into things, and there's both avoiding applications being able to track users across things, right? Where if you have two unrelated applications, but you sign into both of them with the same Facebook account, then actually Facebook changed this, so it doesn't work anymore. But like GitHub or Google, if those applications then start talking to each other, they can find out that they have common users. And one of the primary ways they would start talking to each other is by using the same ad network, where if they're both using the same ad network, then the ad network can find out that the same user has accounts at multiple websites. And so that one's sort of like easy to understand for people of like why I wouldn't want that to happen. It's a little bit more subtle, but the same problem is true at the authorization server level, at the identity provider level, where you actually may not want your identity provider to know which apps you're signing into, which sounds kind of weird because normally, at least in like the consumer OAuth world, you kind of think of your identity provider as the thing protecting your account, where like I use sign in with Google when I want Google to protect my login, right? I don't use it because I have to, and I don't use it because I don't think Google is going to not know things about me, right? Because I have an account there. But once you sort of leave that relatively simple world, there start to be plenty of cases where you're like, I would not want my identity provider to know where I'm signing in. The real world example of this is a driver's license. It's issued by a state department, and then it's used in a lot of situations, most of which you probably wouldn't want your government to know. And they don't. When you go buy groceries at the grocery store and they ask for your ID, that check does not get reported back to the database, right? Whereas online, it usually does, because in order to verify your age, the consumer of that data has to go and check the authorization server, right? That's what a no-auth flow is. It's getting some sort of token issued to the thing requesting it. So that's a lot of the discussions going on right now, is like, how can we make an online system that actually has these properties that share the same properties as the offline system of lack of, not tracking this. So I would like to be able to go to a website and say, maybe log in, but also maybe just say, yes, I'm over 21, and have that website be able to check my age and confirm that I'm over 21 without the thing that's doing the confirmation knowing which website I'm logging into, and without that website knowing who I am, which is a very interesting problem, but it's how it works in the real world. So we should be able to model it.
Are there any Did you see any sort of proposals or emerging standards that are trying to address that dynamic?
Yeah, a lot of the new self-sovereign identity stuff is trying to tackle those problems as like first-class properties in the new system, and that is yeah, a lot of them are adding those goals like as design goals into their specs. That whole world is still so new that barely any of this actually is functional, but there's a lot of proposals and a lot of good experiments going on, I would say.
Interesting.
Yeah.
That's cool.
No, it's really cool.
I wonder.
It's an interesting
I
problem for
wonder if
sure.
any of the sort of hardware approaches where, you have a key that never leaves the device will play a role in this kind of stuff.
Almost certainly. I think everything is moving to that. So most of the new blockchain based stuff, of course, works that way because it's all based on cryptography to begin with. And the assumption is that you have, usually they call it a wallet, and that is a private key that is then used to do all sorts of stuff, right? It might be deriving other keys off of it or signing things, whatever it is. So they all work that way. In that world. And then even in the OAuth and OpenID Connect world, we're seeing a strong push towards private key based methods of authenticating various things. So a lot of the new specs in the OAuth group are around using some form of private key to either sign requests from a specific instance of an app or an entire like class of app or whatever it is. So yeah, I think everything's moving towards that, and the fact that we now have like easily accessible hardware tokens, which are built into a computer or a phone, which means they actually are in everybody's hands. We actually have the ability to use them and deploy systems at larger scales that use it instead of waiting for people to have to like specially buy this new thing. Like the YubiKey is great, but you have to buy it, right? Whereas that already
Right.
exists in your phone now.
Yeah, that makes sense.
Yeah. Yeah. So the idea with like the age verification, I should be able to present something to you that you can verify without going over the network, or at least without saying who you are when you go. And maybe you have to fetch a key, but you don't have to say who you are when you're fetching the key. You should be able to verify it looking at it without actually seeing all of my information. So like when I show my driver's license, I'm actually showing you a lot, right? I'm showing you my age, but also my actual birthday, also my home address, also my legal name, and none of that is relevant. The only thing relevant is, are you over 21, right? At least in the US. And so the idea is using computers, we should be able to do better than a driver's license. We should be able to provide only the information needed and not more. So I would like to be able to present something to you that you can verify that I am over 21 without also revealing the rest of my info, and you shouldn't have to go back and call into a central database to find out.
It's like a thumbs up or thumbs down for that specific attribute. That's all you need to know,
Yeah.
assuming you trust, whatever that system
Assuming you
is.
trust the issuer, yeah, which
Yeah.
is there's always going to be some assumed trust there because you have to. But yeah, assuming you trust the issuer, then you should be able to accept a simple thumbs up, thumbs down. So you have to know who the issuer is and have some rule about whether you trust it, and then you will believe the answer. And that's how it works in the real world. Like sometimes you go to, like if I go to another country and show them my Oregon driver's license, they look at it like, what is this? They don't trust it. They don't recognize that government, right? They want a passport because they recognize the US government, not the state government. Yeah, let's see. We had some other questions earlier on. What can we grab from there? Let's see, this one's a little bit long. Let's see if we can figure it out. There's two parties, A and B, both have a traditional front and back channel, single page app and API. B will call a public API with OAuth, okay. Something with an OAuth access token. We can register an OAuth client in A, yeah. Getting the client ID and secret is what B will need for the OAuth flow. Both A and B will be installed on premise, so we can't set up B in build time, only in runtime, so we set the ID and secret through B's single page app. In this scenario, B is considered a public or confidential client. Oh. The question is, or the distinction between these two is whether or not anybody else will ever be able to see that, get a hold of that secret or change it in some way. So if you can deploy the app where the secret stays secret, it's a confidential client. And that is traditionally done with putting, doing a sort of out of band registration step. If you go to the developer website, do some sort of registration thing, get a client secret, and then put it into your source code or your config file, where it's then not visible to anybody using it. That's a traditional confidential client. In this case, you're saying you can't do it at build time, only at runtime. So you set the ID and secret through B's single page app. The question is, how did you get it? And how do you authenticate the fact that you're able to set it in that app B? Right? So if you're getting the client secret,
how are you storing it? Because the concern that I have reading that one sentence is if you're getting a secret and then setting it in a SPA, that's a concern. However you get that secret, whether or not you trust it, if you're storing it in the SPA, that's a concern. You generally don't want secrets kicking around your SPA apps.
Yeah. So if you have a way to store the secret in the app B's API server side, that's fine, because it'll stay a secret, right? As long as the way that you set it is not something that can be repeated, publicly without logging into it. So it's only a confidential client if the secret remains secret, and if the way that you got the secret was something that is restricted, so that only like known parties can even get a secret. That's actually where there's this middle ground between the two, which is what OAuth 2.1 is doing, is defining the credentialed client, which is between confidential and public. Credentialed meaning it has a secret, but it was obtained in a way that can't actually be verified that it was a legitimate client. So this might be an example of that, depending on how you got the client secret. So, for example, the simplest example of a credentialed client is a mobile app, where you don't ship a secret at build time because it wouldn't be secret. So the user downloads it, and the first thing that app does when it boots up is it goes and calls out to a registration endpoint to get a secret. Now, that happens over HTTPS in a back channel, so that's all secure and all that. But that API call itself is not authenticated, so anybody can make that call, right? Anybody can make that API call. There's no way to know that it's like the real app making that API call. So that's not a confidential client, because confidential implies that the identity of the app is confirmed. However, it is a credentialed client because after that is issued, the mobile app can keep the secret safe in a way that can't be extracted. And so it can use it in the rest of its life cycle of every OAuth flow from then on is done with the same client secret. So it is able to get the rest of the assurances that the secret provides. So that's the credentialed client. So your situation may be that depending on how the secret is obtained.
Yeah, one thing I can say just from experience over at Okta, and this may not fit this description exactly, setting aside the SPAs for a second, I've seen a situation where we have two resource servers connected to different Okta orgs, that have established trust between them. This is where we have big companies that maybe have subsidiaries, and those two resource servers can communicate with each other via client credentials. So they can get tokens and they trust each other. And then they can provision new Okta applications complete with client ID and secret, and they can pass that information between each other and store it for use in other applications. The key thing there is that it's all happening in a between confidential clients on the back end. None of those secrets ever find their way down to a SPA or any sort of public client.
Yeah. So in that case, the only things that can create new clients are previously registered clients, right?
That's right.
Yeah. So then they're all confidential clients at that point.
Yeah, at least in our experience, that's kind of like an advanced configuration for, like big companies that have subsidiaries or big companies that have partnerships with other companies and want to be able to dynamically allocate new OAuth applications on the fly. Not too common, but we have seen it.
Yep. Okay, let's take a look at this question. If you have both the B2B and B2C API, what's the best way of protecting the B2B API so an end user cannot get the B2C access token from the browser and pass it to the B2B API directly? So that sounds like you need to know which, I guess there's two ways to do it. Either knowing which clients are allowed to access both APIs, but if you want the same application to access both, that's what audience is for, right? Does that seem like a good use of audience?
That's what I was thinking. Yeah, that's what I was thinking.
So you make an audience for each API where you say, my B2B audience, here's my B2C audience, and then the access token or the APIs check the audience value. So you have the APIs say, yeah, blah, the signature matches, or this token isn't expired, et cetera, but also check the audience to make sure it's directed at that particular API.
Yeah, so it's like the token is valid, but it's just not meant for me, so I'm going to discard it.
Mm-hmm.
You touched on I don't even know if I'm pronouncing it right. GNAP, is it NAP or GNAP?
Yeah, it's GNAP. This was a very heated debate in the mailing list and somewhat in person of naming that, but yes, it is GNAP.
It's like GIF and GIF. We talked about it before on this, but maybe you can refresh mine and other people's memory about what's going on with that and how it ties into what is maybe anecdotally being called OAuth 3.
Yeah, this came up this morning. My inbox was flooded because it hit the top of Hacker News, which is usually not a good thing. So this is still on the front page of Hacker News right now, and it is 305 points now, 156 comments. It is a long discussion. I'm not impressed with most of the comments, frankly, but what's going on here is OAuth 3 doesn't actually exist, but there's a new effort to improve OAuth 2 called GNAP. And it's gone through a bunch of different names. It used to be called TXAuth or transactional authorization. And Justin Richer has been the sort of primary driver of that effort. And he's written about it several times, talking about why we need something that's OAuth 3. And actually, a lot of these were originally done as sessions at... No, I don't want to sign in with Google. A lot of these were done... Yeah, speaking of sites where I don't use Google sign-in, Medium can just get lost. Get out of here.
They also
But
use the
yeah, a lot of
implicit flow, at least at last check. FYI.
yeah. Should I sign in with Medium and see if it still does?
Let's see if it, yeah, I'm curious to see if they changed it.
Yep,
Oh, still
that
does.
just turned red. Wait, they returned an access token also?
Yep.
That's bad. I'm not going to show that on stream.
It doesn't show anyway, which I guess is a
Okay.
feature of StreamYard or something. That's pretty cool.
Oh, it wasn't showing on StreamYard because it's showing only the browser contents, and this is like out of the browser.
Ah,
I see.
interesting.
Well, you can see at least the icon is red. Um,
Yes.
but yes, so the general idea is to improve OAuth 2 and address new use cases that have been coming up and aren't able to be added to OAuth 2 or would be very awkward to add to OAuth 2. And this has gone through a few names: transactional authorization, TXAuth. It was originally being discussed at the OAuth working group at the IETF, and I believe it was, gosh, now I'm trying to remember what year. It was last year. It was last November. I think it was in the Singapore one in November, which is almost a year ago now. I miss traveling. That was where it was decided to actually create a new group. I hope I'm remembering the date right. Anyway, it was originally sort of being discussed at the OAuth group, and then we decided to spin it off into a new group, and spin it off into a new group so that it can be worked on sort of independently without getting messed up with all of the OAuth work, because there is still a lot of OAuth work going on as well. Also, to add, frankly, a lot of the features that this has. So a lot of the like push authorization requests and rich authorization requests, a lot of that stuff is sort of being done in parallel in both specs, and they're influencing each other. And OAuth 2 is getting a lot of those features, but this GNAP, or Grant Negotiation Authorization Protocol, is the sort of like from the ground up version of what would it look like to build a protocol with these features if we weren't bogged down by the original design of OAuth 2. So
So this is actually its own working group, which I didn't realize until just now.
it is, yep, that was a relatively recent change where it, like this charter was started in, I guess, June. What's the first version? Yeah, June. And that was the first draft of the charter. It was finally approved. So the charter, as of July, is the official group called Grant Negotiation Authorization Protocol Working Group, or GNAP. And this group is developing the spec called GNAP, also by the same name. This is the charter. You can read all about what it is scoped to do. For example, it is not making extensions to OAuth. It is doing things that may not be compatible with OAuth. But many of the use cases are the same as OAuth use cases. But yeah, it is not.
I kind of feel obligated to refer to it as NAP just because it'll annoy people. That's just me.
Yeah,
But I
mean,
won't.
yeah. So it's not OAuth. I have this page here called OAuth 3, which is the one that hit Hacker News, and I just updated it this morning to say this because we don't want people to think that it is actually OAuth yet. It's not. It might be later. It's very possible that this gets rolled up into the OAuth working group at some point in the future. Who knows, right? Like, anything can happen. The thing is that there's a lot of the same people working on both. So there's a huge overlap in both the functionality as well as the actual people doing the work. So it was mostly just a sort of an organizational thing to separate it into its own group. Yeah, so that was some morning fun of reading through all those Hacker News comments, which are not always the best, to put it mildly.
And we also learned this morning that GNAP is actually a dictionary term. I don't know if it's pronounced the same way, but GNAP is a dictionary term. So there might be
Yeah.
some
It's
interesting
also
disambiguation there.
it's also what Smurfs say.
What?
And I guess
Really?
it's yeah. Oops.
Nice.
Put that back. That's what they say after they turn into black Smurfs, apparently.
Huh.
Okay.
Wow.
Uh, okay, here's a question. We have a single page app deployed alongside a resource server. It has a mobile client and also a REST API for third-party access. Would authorization code with Pixie work for all three use cases? Seems like it, right? Single page apps can
Yeah.
use Pixie. Yep, that's the best way to do it for single page apps. That's the best way to do it for mobile. The REST API for third-party access should definitely use OAuth, and Pixie would be the most appropriate there. The only things that it wouldn't work for are if there's no browser on the device that is trying to get an access token. So like Apple TV. Then you need to use the device flow, which is a different flow to support on the authorization server.
For REST API for third-party access, I guess the caveat there is at some point you need to interact with a browser to get the access token or to get the code to exchange for the access token. So for the authorization request, you still need to have some way to interact with a browser, even though it's a REST API. But as
Yeah.
long as that fits, then you should be able to use it for all three use cases.
Yeah. What else? What else happened?
I was just poking around to see if there were any kind of GNAP like reference implementations or anything that you can play with right now. I don't really see
Justin
anything yet, but it's early days.
Justin did do one. I know he's been building this as he's been building the spec. I actually think I have a link for it. And oh, I should probably go to the homepage of that. So this, I'll drop a link. This is sort of, I guess, the reference implementation because it's Justin Richards' implementation written in Java. So he's been keeping it up to date. Mostly, I think. Although 5 months ago seems like a while ago.
Hmm.
But yeah, he's been keeping this up to date with the spec and trying things out in here. So I
Neat.
haven't actually run it myself. I have no idea how it works or what it does, but it's got a client and a server in here.
Hmm. I'll definitely have to check that out. Neat.
I don't really do Java, so most of that is like a foreign language to me. Yeah. Yeah. Let's see. What's happening in the OAuth world? So OAuth events coming up. This is the last day of IIW, so sorry if you missed that. Only a little bit of OAuth stuff going on there. I mentioned a couple of the sessions, but the vast majority of the sessions are all the self-sovereign identity blockchain things. This is our happy hour this week. We'll do this again in 2 weeks. And then we have these interim meetings coming up, and we'll probably do a few more as well. We're not going to do sessions at IETF again. I've actually kind of enjoyed this alternative of rather than cramming everything into a week and having to coordinate with all the rest of the working groups, we just are doing our own meetings on our own schedule. So the next one is Monday, talking about the security BCP updates. After that, the next week is WebID. And then Depop, which is that proof of possession, which is one of those ways of adding cryptography and public key signing into the OAuth protocol, so that you have to have something in addition to the access token in order to actually use it. So that's
The address there is a little obscured by our happy hour logo.
Oh,
Maybe you can paste that in
I
too.
didn't even notice that. It's events.oauth.net. Maybe if I resize this, it'll work. There we go.
There you go.
Okay, cool. Last question, and then we're gonna wrap this up. If a non-mobile single-page app is using auth code with Pixie, non-mobile single-page app, yep, in a web browser, I assume. If the access tokens make it to the browser, then are we still gaining much benefit from using auth code grant type instead of implicit? Aha, yes. So, good question. There are two different problems to consider when you're talking about OAuth. One is, well, there's actually many different problems to consider. Relevant to this question, there are two problems to consider. There's getting the access token, and then there's storing the access token. And they are different problems. And it's very important to think about them differently. So the problem of storing tokens, the reason they're different problems is because the attack vectors for taking advantage of them are very different. So if you are talking about the challenges with storing tokens, then the general risk in a single page app is that there may be a cross-site scripting vulnerability which allows code on the page to access a local storage or a cookie or however you're storing the token. That's the sort of general worry there. The other main way that tokens can be stolen out of single page apps is if code on the computer is running and is accessing the browser's storage. So this is how you can end up getting your Google account taken over, even though you've done all your two-factor auth and stuff. If someone is able to get you to run a program on your computer, it can just essentially clone your entire browser, pick up the file that's storing all the cookies, including the ones that say you've already done two-factor auth, transport them to the attacker's browser, drop them in there, and now they're logged in as you. And 100% has happened many times. People have lost their very popular YouTube channels off of that because of that. So those are risks. Those are different ways that storing tokens might be hacked. Now, those are clearly problems, and there are sometimes not great solutions. Like the only solution to avoid the browser cloning one is don't run arbitrary code on your computer, which is usually pretty easy to avoid, except people do download apps. So any of those desktop apps can be cloning your browser without you knowing it. Not to make you never want to run an app again, but this is why Apple's doing app signing and things like this, right? The cross-site scripting one is hard to solve because the only real way to solve that is to never use any third-party scripts ever, right? Anytime you have the ability or the possibility of a third-party script loaded onto the page, there's a chance that somebody else's code might have a vulnerability that you aren't even aware of that's now running in your app and is vulnerable to cross-site scripting. So yeah, those are problems. The solutions are there's some ways to avoid them, but also the ways that an attacker can pull that off are relatively limited, right? And relatively targeted. Like in order for someone to do that, you have to kind of go through a lot of trouble to get someone to be vulnerable to this attack. So that's that problem. The other problem is getting the access token. Now, getting the access token, there's a whole new kind of ways that might fail and be attacked. Because getting the access token involves interacting with two different machines over a network. And that's usually through a redirect or whatever that is. And that's where you get the advice of not using the implicit flow. Because the implicit flow issues the access token in a redirect. And now all of a sudden you've got the browser has that available. Any browsers have it available. So you still have the cross-site scripting vulnerability there as well to think about. You also have to worry about now other things on the network, other things maybe logging stuff, whatever. There's just this whole new world of ways that can be attacked. And that's only from the application's perspective. If you're talking about this from the authorization server's perspective, the authorization server can't ever know that the implicit flow succeeded. All it knows is that it sent an access token somewhere. It doesn't actually know that it wasn't stolen. So It's actually way worse from the point of view of the authorization server, where you just made it up an access token and sent it out into the world, and you just cross your fingers that it worked. So with Pixie, the authorization server does not throw an access token out into the world. It does that with the authorization code. And the authorization code is only able to be redeemed by the particular instance of the app that started the flow, which can be confirmed by the authorization server. So not only have you reduced the number of ways an access token can leak, because now the only way that an access token can be stolen during the issuing of it is if code is running on the computer and able to look at network requests. You've also now made it so the authorization server does in fact know that the token made it there. So yes, there's still the problem of storage hasn't changed. The security model of storing tokens hasn't changed between implicit and Pixie, but the security of issuing the tokens has, and it's a huge improvement. So they are separate problems, and it is worth actually improving one even if we can't solve both at the same time. So that was a longer explanation than I thought, but
now it's very clear. Yes. The sending it back in the redirect, the impact on the authorization server, I think, is not often thought about. And then from the client side, whatever issues there are with token storage, you're just expanding that surface area of attack by having it in the browser's URL bar.
Yep, exactly. Cool. Well, we'll wrap up with this, which is how often do we do these? Right now, we're at an every 2 week schedule. So this time on Thursdays, every 2 weeks. And we're going to do that for as long as we can. And the best way to find the next one is on events.oauth.net. We'll always post a link to the next one, and I'm going to do that as soon as we wrap up here. So with that, thank you everybody for joining. It was a fun conversation.
Thanks everybody.
And yeah, have a great rest of the day.
See you next time.